So we're going to start looking at quadratic relations, or what we call conic sections. Quadratic relations are essentially anything that contains a second degree term, or a power 2. And they all happen to be generated from this cone here. So these are actually sections of this cone. So the quadratic relations we're going to deal with are the circle, okay, and it's related to an ellipse. So circles and ellipses are essentially the same thing, except the ellipse is an expansion and compression of a circle. The other one is a parabola, and we've dealt with parabolas along the y-axis here, but we could also deal with parabolas along the x-axis, or sideways parabolas. So we will introduce those as well. The new one really is the rectangular hyperbola and hyperbolas. So the rectangular hyperbola is similar to what a circle is. It's a symmetrical hyperbola. Okay, so a hyperbola is this shape here. And this shape would be familiar to you if you can imagine like a flashlight shining against a wall. A flashlight shining against a wall will create this type of pattern on the wall. Okay, and it's basically because it is cutting through the cone. So imagine a flashlight is a cone. Okay, the light on the flashlight comes out in a cone, and as it hits a wall, a flat surface, it'd be like cutting through that cone. So it'll create that kind of shape. Now, rectangular hyperbola is a little bit misleading because really we should really call this a square hyperbola, because just like a circle is symmetrical, square is symmetrical, rectangular kind of implies it's not symmetrical, but it's actually, the rectangular hyperbola is essentially a square hyperbola, and the hyperbola would be a square hyperbola or rectangular hyperbola that's been compressed or expanded, much like the ellipse to the circle. So again, all these second degree relations are going to be generated by cross section of a cut of a cone. So if we slice through this cone in different ways, we'll get different quadratic relations. So this cone is the way we generate this cone is, imagine having this line here, so it's a diagonal line, and rotating it around an axis. And we're going to generate a top cone and a bottom cone. And these surfaces are actually called napes. And this line is called the generator. And different slices will give us different shapes. So for example, if we slice straight through like that, we get this circular shape. If we slice through at a slight angle, that circle gets a little bit distorted, and we end up with this elliptical shape. Okay? If we slice through just perfectly parallel with the generator, the shape that we get this kind of shape like that, and we're going to end up with a parabola. Okay? And a parabola is basically the boundary shape between an ellipse. So imagine if we just kind of slice through a little bit more this way, it's going to this line will cut through this generator and create an ellipse. If we angle the line this way a little bit more, it's going to start cutting through the top part of that cone. Okay, so this parallel line will never touch that top cone, whereas if we change the angle a little bit, it'll start cutting through the top of the cone, and those generate the hyperbolas. Okay, and we'll take a look at some animations to help us kind of understand this as well.